Here we have an exponential equation, and in this exponential equation, we have to solve for x. That is, we have to find the value of x. Okay, so in the given exponential equation, what I'm going to do is, we have square root for the complete stuff on the right side. That is, for this complete stuff x to the x to the power, we have square root. So whenever we have square root, the square root can be written as exponent, that is 1 half. So then we get x to the x to the power whole to the power 1 half. So I have written the square root over here as the exponent for the stuff inside the square root. And now let's consider the power of a power rule in exponent. That is, let's consider the base a and m as the exponent for a. And let's consider another exponent for this complete stuff a to the mth power. So that is n. Okay, so now we have a to the mth power, and for this complete stuff we have the exponent n. So whenever we have two exponents like this, what we can do is we can multiply these two exponents. Then I am getting a to the power m times n. So I am going to use this power of a power rule on the right side of the given equation over here. Okay, let me apply the power of a power rule. So on the left side, I'm just writing the stuff as it is. That is x to the power square root of x. Okay, now here we have the base x and the exponent is x. And for this complete stuff, again, we have the exponent 1 half. So what we can do with these two exponents? We can multiply these two exponents according to the power of a power rule in exponents. Then we get x to the power. When I multiply x and 1 half, it will be x times 1 half. So in the next step, x times x to the power square root of x equals to x to the power. So when I multiply x and 1 half, I have to multiply this x by the numerator 1 over here. So when I do so, x times 1 is just x. I'm getting x over 2, the exponent. Okay, here let's consider another important property of exponents. That is, let's consider a to the mth power equals to a to the nth power. So here the two terms are equal. So what is the base on the left side? A. What is the base on the right side? That's also a. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. That is, m must be equal to n. So the same property we can use over here in our problem. So here the two terms are equal with the same base. That is, the base on the left side is x, the base on the right side is also x. So what can we do? We can equate the two exponents. So then I'm getting square root of x equals to x over 2. Now we have to solve for x in this equation. So for that, my first work is to get rid of this square root. For that, I have to square both sides. So when I square both sides, square root of x whole square and x over to the whole square, and here the square root and this square will cancel. I'm just getting x on the left side. And when I take square for a fraction, the square, I mean the exponent, can be taken separately for numerator and separately for denominator. So then I'm getting x square over 2 square. Okay, then we get x equals to x square over the value of 2 square in denominator, it's 4. Okay, so to solve for x, so we should get rid of the fraction on the right side. For that, we have to get rid of the denominator over here. So for that, I have to multiply both sides of the equation by 4. Then this 4 will cancel out. I'm getting 4x equals to x square. Okay, now let me subtract 4x from both sides. When I do so, I'm getting positive 4x, negative 4x will cancel out. I'm getting 0 is equal to x square negative 4x. Further, this equation can be written as x square negative 4x equals to 0. So we have 0 here on the left side. It can be taken to the right side. Okay, now we have to, I think we can solve and, we can factor and solve this equation over here. So what is the greatest common divisor for the two terms on the left side over here? It's x. So both the terms are the greatest common divisor x. So x can be factored. If I factor x out, so what do I have left in the first term? I just have x left. And if x is factored, what do I have left in the second term? Negative 4 equals to 0. Even if I distribute this x to this x and negative 4, I must be getting the original stuff, x square negative 4x. Anyways, we can check it. So when I distribute this x to x, x times x is x square, and x times negative 4 is negative 4x. I'm getting the stuff over here. Okay, here the product of these two terms equals to 0. So whenever the product of two quantities equals to 0, either the first quantity can be 0 or the second quantity can be 0. So x equals to 0, it is already solved for x. Okay, now let's solve for the x in the second equation over here. For that, I have to add 4 to both sides. So when I do so, negative 4, positive 4 will cancel out. I'm getting x equals to positive 4. So I'm getting two values for x. One is x is equal to 0 and the other one is x is equal to 4. But when I take x is equal to 0 into the given equation, what will happen? So I have to plug in x is equal to 0 over here. Then I'm getting what? 0 to the power of square root of 0. Actually, the square root of 0 is also 0 equals to square root of 0 to the power 0. Anyways, so before checking whether these two quantities are equal, so actually 0 to the power 0, usually in calculus it will be considered as indeterminate form. So it's not a valid stuff. 0 to the power 0 cannot be considered as a valid stuff. So when x is equal to 0, we don't get a valid stuff in the original equation. So we can ignore the first solution, x equals to 0. We can consider the second solution, the 4 in the given equation. The value of x is 4.